Today, we're diving into a visual shortcut for messy digital logic, the Karnaugh map. Logic expressions can get really long, and that makes for clunky, inefficient circuits. So, there has to be a better way to clean this up, right? Well, there is. Often, you'd start with a truth table. It just lists out every possible input and output. But here's the catch. With more inputs, these tables get huge really fast. From that table, you build what's called a sum of products expression. You just grab every term that gives you a 1. And boom, we're back to that long equation. Trying to simplify this with algebra, it's a real headache. But what if you could just look at it and find the simplest answer, kind of like reading a map? And that's where the Karnaugh map, or K-map, comes in. It's a visual grid for doing just that. The more variables you have, the bigger the map gets. Simple enough, right? But check this out. The numbering is kind of weird. It's not sequential at all. And that weird order is the secret sauce. It means adjacent cells only differ by one single variable. So using it is kind of like solving a puzzle. Let's walk through how you group the ones. First thing you do is take your function and plot all the ones onto the map's grid. Now you look for the biggest possible groups of ones. Here we can circle this block of 4. Inside this group, the B and C variables both flip, so they cancel out. All that's left is A. All right, next we gotta group this last one. And remember, groups can totally overlap to stay big. In this vertical pair, A is the one that changes, so it's gone. That leaves us with just BC. And just like that, look at the difference. That huge expression just becomes A plus BC. So why does this matter? Well, this simple trick has huge real-world benefits for our electronics. I mean, this directly leads to the faster, cheaper, and more reliable tech we all use every day. K-maps are an awesome tool for us humans, but it makes you wonder, what about hundreds of variables?